All right, we're live. I've got Mitch Hodges here with me from GreenPWR. Mitch, I really appreciate you coming on the show and sharing your story.
Yep, thanks for having me.
Yeah, so let's jump right into it. So you have a product named GreenPWR, and you're in the solar renewable space. So tell us a little bit about what this product does for the customer.
Yeah, for sure. So this is a specialized solar inverter for generating hot water for the house. So you can kind of think about it like with solar energy systems, we have inverters that tie to the grid such that you have the solar panels generate electricity, convert that to AC, and tie to the grid. You sell it back to ComEd. You can use that as well internally. Now, where we have more growth in the field as well, and also more need on the grid itself, is how do we store energy? So one of the basic things that always comes to people's minds are batteries when you have smaller local systems, hydro, big things like that, of course, exist. But a different approach that is, of course, another thing to investigate is how can you actually do demand side management, which is how can you most adequately use the energy in your own household. Now that has a lot of interesting complications in that it does save money for the consumer, but how it does is a little bit complex, and I'll break it down. So around where we are, which is the Chicagoland area, typically most people sign up for flat rate electricity. So in these instances, we have net metering. So on that, if I have additional, like let's say I have on this house a solar array tied to the grid, selling energy back to ComEd. So we will sell energy at a rate, and we'll get energy back at that same rate when we aren't generating. So let's say I have an extra 2 kilowatts during lunchtime, for instance, kilowatt hours during lunchtime. Then at 6 p.m., I can get that same couple of kilowatts of energy at the same cost. Now, just thinking about it, that's actually bad for the grid, just at least from a business case and on the end of energy storage. So on the grid's perspective, let's say we have a lot of renewable energy, like California does, like Hawaii is starting to get there, other areas of the United States as well. We have a lot of energy around noon, so much that we actually have to not utilize everything that's available on the grid. So your possible cost for energy, like what the utility would pay, is lower because it's so plentiful. But once the sun starts to set, people come home from work and they need to start using their appliances. Everyone wants all that energy. So without energy storage, you can put as much solar in the world as you want. But if at 8 p.m., 7 p.m., 6 p.m., in that range, that peak range, if that's when you need all your energy, I don't have any solar really to support that. So it has to come from energy storage systems.
So like everyone knows batteries are a form of energy storage, and what's unique about what you're doing is you're using water as that energy storage system. Is that right?
Yeah, exactly. So kind of to hop back on that train of thought. So in order to balance that out, either we need to do a handful of things. One, store that solar and renewable energy as best as we can in cost-effective means. Or two, if you don't have so much solar utilization, let's say on the grid, let's say you're only up to maybe 30, 40, and you have fossil fuels backfilling and everything else, that's about your limit, really, until you start to have issues where you can't utilize energy. So on our perspective, where the SunHopper, that's our GreenPWR product, where that fits in is for that solar array, we're tying to the domestic hot water heater, which is the second largest energy consumer in the household. So for most houses across the US, you're talking about 20% of energy is used for heating water. Space heating, space cooling is by far the largest, but when we're tackling these systems, this is the next biggest one we can kind of localize and optimize. So now on that end, the hot water tank is a thermal energy storage device. So it's not that we're getting energy back from it, we're utilizing the hot water. So it sounds relatively basic in that we're really just getting water hot, but how we're doing it is where we have all of our special sauce. So we have our dynamic learning algorithms on that end that are monitoring weather data for the next couple of days, along with energy, time of use energy rates from the utility. And from those two, along with watching the thermostat trip events with some of our patent pending algos, we can determine what the water usage is, when the water is needed, what the forecast for weather is, estimate what the PV output is. Knowing the cost of energy across the day, we can then backfill and use the AC grids at the most cost-effective times for the user.
Right. So let's break that down with an example. Let's say you have, a regular household, two people are working and then they come home from work, so around 5, 6 p.m. and that's when they start utilizing the hot water. Maybe they're taking a shower. So how do your algorithms kind of take that real world scenario and translate it into that energy storage requirement?
Yep. So try not to make this too complex of an answer, but there are a lot of little complexities there. So even if we just think about heating water, the older water heating systems, they'll just be up and on all the time. Unless you have something like a timer just to store energy for nights, you then run into risks where you don't have enough hot water. So where our system comes into play is at the start of each day, we pull weather data. We can then estimate for that current day and the next day, how much energy do we expect to get from the PV array? We then have our adaptive model where we were learning to see roughly like how much energy, how many gallons or liters of water are needed by the household. So then we have that schedule, effectively every 15-minute schedule, where we see here's the water demand, here's the input energy, and not to overly simplify it, but a simplistic approach we can look at is we take the net energy. So do we have excess energy or do we have a negative energy? So then following that path, if we have excess energy across all hours of the day, we then actually don't need to add any AC. That'll be great. That'll be a nice, sunny, bright day where we get all the needs of the household. Now, if we flip this side, like let's say it's raining part of the day. So raining in the AM, for instance. So now the algorithm is going to go through, see that we have sufficient energy to not sufficient, but we have some energy to store in the afternoon before the user needs it. We have to I wouldn't say backfill, but front fill energy. So the algorithm smartly sees how much energy we need to add. It adds a little bit, of course, for a little margin. Tries to store as little as it can using the AC grid. And then when the sun comes out, we keep monitoring to ensure the thermostat is actually reaching the trip event.
That's cool. So it's kind of like you're utilizing a combination of the usage patterns as well as the real-time weather data, and then even some historical data, right?
Yes, that's right.
That's super cool. And that's what I find like super fascinating about something like this, where, on the one level, you can kind of explain it to the layperson and say, yeah, the water stores energy. The water's the battery. And then once you start digging into it, like the true moat that you've built here is all that specificity and all the algorithms to actually make it work for day-to-day use. Because without those, it might not be the most user-friendly solution. Like it might just be a cool tech feature. But I feel that with what you're adding to it, you're now making it a usable thing that everyone can get accustomed to and incorporate in their day-to-day lives.
Yep, correct.
So how did you start getting into, the whole renewable space? Because let's talk about your background a little bit. I think you started out in consumer tech, wearables, sensors, things like that. So talk us through that journey of how you got to where you are today with GreenPWR.
Yeah, for sure. Okay, so I hope I don't go into too big of a novel here, but starting off the career, in my undergrad, I focused on power electronics. I'm typically looking at smaller systems like battery power systems, stuff like that. So my first job was actually at Motorola Mobility, doing cell phones, things like that. So on that end, I was there for about 5 years, wireless charge and stuff like that. And that's when I really just wanted to do kind of like a change to keep growing, keep learning. So I always had that focus on analog and power though. So left for a few startups in the middle. Those startups focused on some IoT aspects of things, just making devices around the home, wearable devices, stuff like that, smart, and seeing all the different features. So with those several startups I was at, it was nice to just see all these different technologies that could be applied. So it kind of opens up your mind to just say, it's like, hey, even though this looks like a basic problem, if we start adding these smarts to it, we can actually start adding up all these optimization steps. So then following that, I went to one of the big tech companies over there back in the mobile space for a little bit of time. And kind of in my head, I was like, all right, I just want to do something different. I've been in the mobile space already. For me, it's kind of fun, but it's one of those things of like, yeah, I've seen it. I kind of see that technology as plateauing. Like you don't have a lot of growth in the mobile devices. It's like, yeah, almost like the joke you always hear, hey, let's add a better camera, better display, better battery life. I kind of see a lot of truth in that. So then I left corporate went over to the UK for a year to get my master's in renewable energy systems. So on that end, at least my head, and I still see it this way, the renewable energy space is still quite infant. So even though there are a lot of devices currently being deployed, a lot of stuff going on, there's a lot of new technologies to be looked at. There's a lot of new features, new functionality that can be added from all these other spaces. So on that end, spent a year over there, and the master's project I had actually was what turned into the SunHopper product, which we're making now. So met with Simon over at the Hawkinson Housing Project. So he is a director over there, and they do a whole bunch of sustainable housing work, just to see, it's like, hey, how can we make a sustainable housing community? How can we make everything in the community as sustainable as possible? So he's a very smart man with many ideas. Just needs a lot more hands and brains to get all those ideas down and kind of into products. So one of them was to make an improved solar water heating system. So if we do like a big step back in technology, before we had PV panels, if anyone had solar installed on their house, it actually was solar thermal systems. And
Oh,
that would
really?
be heating water. Yes. So typically that is, you have something like a big array of black pipes, black tubes. There's much
Yep.
more fancy collectors for sure that can do this, like vacuum evacuated tubes. And from that, we just run water through it or pass water through heat exchangers, stuff like that, to then heat water. So before we can make electricity, we were heating water with the sun.
Yeah.
So on this end, the whole point with this product was to try to make that installation and reliability much higher than the older systems for water heating use. So those older systems, as you can imagine, having water running through outside on either black coated tubing or through specialized solar thermal collectors, you'll of course have risks for freezing the pipes in a climate like ours, leaks in any climate, and then just all the hassle of the whole system. So those collectors are quite heavy, and some of the collectors as well, that they won't definitely work at all across most of the U.S. But thermal siphon systems, they actually have the tank mounted directly on the roof, and they have a collector right beneath it. So they just use very basic physics to work. Very
Yeah.
simple devices. Great if it's a tropical environment and never freezes. But
Yeah.
across most of the U.S., you have any freeze risk, you can definitely damage that whole system.
Yeah. Plus, that install sounds like a nightmare.
Oh, for sure. Yeah, very heavy system. You have to make sure it can get the tank and the collector up on the roof nice and carefully. And when you do have problems with all technology, you will have end of life servicing, stuff like that.
Yeah.
You've got a lot of weight that you're now dealing with, along with the plumbing that's going outside the house. Yes, and
Yeah.
then with
Super
our
interesting.
system, we're just using PV panels. So that's the nice thing. They're very light. They blend in with the rest of the panels in the house. So let's say someone wants solar for grid tie things, and they also want to do additional solar impact to the hot water system of the house. So it's not a different looking panel. So they're the same array effectively. It's just you'll have a small portion dedicated for our system, and you'll have the remainder of the system dedicated to any other system in the house.
Yeah. So then your install, the places where you go and do these installs, they could either have an existing PV array or you can do that as part of your install, right? You can kind of retrofit it if you want to.
Not quite. If you did have an existing array, so our first product does require a dedicated array. So our next product, which will be coming out once we get this one through certification to the market, that's exactly what we're focusing on. Trying to utilize the panels that already exist on the house, doing all the smart algorithms like I mentioned, and effectively just steering energy to the hot water tank to improve demand side usage of energy.
Yeah, that'll open up your pool of potential customers too, because right now you might be trying to convince people that don't have panels to get panels, which could be a big ask. But then the people that already have panels, they're thinking about renewable energy and sustainability, so it might be an easier sell too for the future.
Yep. Yeah, exactly.
So how was your journey? You started out kind of corporate, and then you joined a couple of startups, and then corporate again, and then now you started your own company. So how was it with those kind of startups that you joined as part of, someone else was leading that startup? What were some of those lessons that you learned now that you're starting your own company, your own startup?
Yeah, definitely quite a few lessons with the different flow amongst all those different startups and also corporate. So my experience when I first started just at Motorola Mobility, very good learning lesson. just in how the product development cycle works, along with manufacturing. So that, I think, by far was the biggest lesson I had right out of college, was how do we actually build hundreds of thousands of devices and then just don't get overwhelmed building all these. So we were just looking at different failure rates at the end of the product when we're in mass production, trying to minimize all these defects and, of course, make good products for the consumer. So that was a huge end there. Very structured. Granted, then you also see with older established companies, some areas you can tell are a bit too structured, where you have, like, let's say, a bunch of different checklists, a bunch of different processes that are in place that were kind of meant and suited towards older technology. So then we're effectively kind of just checking boxes, saying, yes, we did this step, yes, we did that. Now, granted, I understand on that end that it's kind of to help guide, help grow, help mentor people that aren't used to the whole process. But after you've seen it a few times, then you kind of get into an optimization path in your own head. That some of it kind of turns into busy work. Then going into the first startup I left for, along with a couple startups after that, it was the complete opposite. So the first startup I went to, they were growing out their engineering team. So I think they had 1 or 2 engineers on staff, and that was it. Most of the other folks were designers, like ID designers, stuff like that. So on that end, it was kind of like we were starting our own department anyhow. So everything was just what the most optimal steps that we thought were best to make that product. So it was effectively just like starting from scratch. So very similar to GreenPWR. We had to choose like CAD tools, even had to see how we're going to start parts libraries, how are we going to start maintaining all these things? What's the plan for firmware, electrical, mechanical, making sure that all moves together. Yeah, and then back to corporate. So then I just saw very similar stuff as Motorola. Of course, some different things as well, but it's interesting seeing how much corporate kind of puts everything in like template form, makes things relatively smooth operating on, so that at least in the product development cycle, since you've already gone through that development phase with a prior product, or at least the team has, or someone has before we got there, you can then see, okay, here's effectively the lessons learned, and here's a path to go by just to ensure that you have the best chance for success. So, and then hopping over to GreenPWR, this is definitely my first large power electronic device, like over, let's say, 1 kilowatt. So I've done little things, hobby stuff for sure in the past, where it was in that same ballpark of energy. So interestingly, at least the power stage, that stuff worked quite well, followed the simulation very well, followed all my hand mass very well. The complications arose from all the safety functions, which are required for certification. So that was a pretty large learning lesson, where when we were going through the engineering phase, we were trying to see how do we most optimally do this, and then try to see it and understand all the specs. And of course, as we keep going and keep digging into things, we see it's like, oh, actually, this system we first designed, we do have these limitations, and we saw some things were much more difficult to manufacture than we initially expected. So actually, a couple of our initial safety systems, we had to completely re-architect, which was just, we're new in this space. It's common in this space, but just going through this our first time, you kind of have your own thoughts when you go into the simulator. You start to see reference designs, and then you have that almost unlucky innovation in your head. You're like, oh, this method should work. You start to go down that path. Simulation looks great. You get the hardware back, and you see, oh, this is why it doesn't work. Then you have to go through and start to do things a bit more traditionally.
Yeah. And this applies, like certification applies not just to hardware, but also to firmware and software. And we talked a little bit about this earlier, like making sure that you're meeting all these specs. What was your biggest like takeaway from that? Like if there's someone else going through UL certification, what would you advise them?
Yep. So, and I had the foresight to do this as well, just because of a startup in the past. But it is make your biggest like product requirements document PRD as you can, and just tear apart the spec. So especially for ours, we were doing a dual certification. So America, which is UL, along with internal arc fault detection, and with Europe, so that's EN 62. So just knowing those standards, going through them, breaking them apart, just to see every little detail that you must meet. If you fail one of those criteria, it's going to be an expensive research or partial research when you actually have to go back in.
I think you did a good job of kind of taking parts of that UL certification, implementing it in the hardware, and then leaving other parts to the firmware. What was kind of your thinking around that?
Yep. Yeah, so to jump back a little bit on that, so that applies to UL 19, or so I'm just spitting out numbers here, but UL 1998 or EN 6 IEC spec. So with those two specifications, we do have some requirements for firmware and software and also ASICs, so specialized ICs. So if we implement any kind of safety functions that are critical for the application, we have a few different requirements, a few different levels of those two specs. So it's like Class B or Class C devices. This also exists for industrial devices too, like SIL 2, SIL level, SIL 2, SIL 3, stuff like that. But nonetheless, when going through those specs, we then start to see where things get more complex. And some of this is now, instead of kind of more straightforward hardware certification, this is now we have a ton of documentation, a ton of other verification we'd have to do, having things in code. So one of the unfortunate things is we have to have one or two, it's really like 1.5 of our safety functions that are built into firmware. So just because of that, we had to incorporate all of effectively the software for safety critical applications built in there. So all the safety tests and self-tests.
Yeah.
So a few items, though, we were able to keep completely off chip, effectively in little FPGA devices. So the nice thing with that is, since there isn't any code running, it's just a gate array. It falls under the ASIC category. So you don't have to do all these CPU self-tests. There's no RAM to self-test. There's no flash to self-test, stuff like that. It's just a self-contained logic block, effectively. So we try to do that as much as possible. And it was just those one system we just couldn't. It would effectively blow up what we'd have to do. In software, it was very easy. Honestly, I think it's on the order of 100 lines of code. If we have to do that in hardware, probably the hardware's as big as our whole inverter is, just to do that. Yeah, so that's where we just had to make the decision of, all right, we have to do it for this one, but let's minimize how much safety critical application work that we have to do in code.
Yeah. I think when I first started at MPC, that was one of the things that I saw as well. One of our earlier projects, it was they're currently getting certified for FDA clearance, and they're having such an easier time because we put a bunch of critical stuff in hardware using the same kind of programmable FPGAs.
Yep.
And it just makes the certification process so much easier for the firmware, for the software.
Yep, exactly.
So that definitely a key lesson there, figuring out how to balance that out. I want to jump real quickly into the sales aspect of it. So, you're an engineer background just like me. How did you kind of grow into the CEO role that you now have? How are you embracing sales, handling customers, things like that? What was that journey for you?
Yep. So we're definitely still early on the sales end. So as an engineer, I definitely want to get the product out and through certs successfully right there. Now, it's kind of a goofy experience, I'll say. Maybe not too goofy, but a lot of people, like right out of high school and when they're getting their undergrad, they'll have a little side job, stuff like that. So when I was getting my undergrad, I actually was in Circuit City selling TVs, audio equipment, stuff like that. So I know it probably dates me. They've been out of business for a few years now. So, but on that end, that actually was a very good learning experience there as well, of just seeing and how to explain things to different people. Like, you'll definitely have your few different groups of people. You'll have your people that just want, like, they don't understand all the technical aspects. They just want something to work in their house, and they want to make sure it works and reliable. So you had a group of people like that. You had another group of people that were crazy techie and wanted to talk about all the latest tech stuff with you and wanted to see all the greatest and kind of bust your brain just to see what you know about all the products, make sure you know everything going on. And then you had like some of the folks that were kind of in the middle. They knew some things, they knew what was important to them, but they didn't know all the crazy tech detail. So that if you try to talk into too much tech detail, you would kind of lose them. So I see very similar stuff when we're talking to installers, customers as well for GreenPWR. So what we've been doing is focusing on trade shows, since we're a newer company. So we've been doing Intersolar along with RE Plus. So with both of those different venues, we've kind of seen very, very similar group of folks. You have some people that they see the product, it just clicks in their head right away. It's like, oh, this does this. I haven't really seen this and too much competition in this area yet. And we can then just talk about how our algorithms work, and they just jump straight to the conclusion. It's like, oh, this is a great idea. It's like, this is awesome. Here's a business card. Let me know when it's all ready to go. And then we have other folks that are kind of on the flip side, where they just understand the end of solar grid-tied systems. So then we start to explain, yeah, this one's not grid-tied. So the nice thing is everything's local to the house. We're optimizing to that system, and we don't have interconnection to the utility. So there is no interconnection permit that you have to get for our system. So then a few folks are kind of scratching their heads saying, well, why don't I just get a bigger grid-tied system? And we start to explain, it's like, well, we have this case or this case. There's several cases why you wouldn't. But we kind of lose them because they didn't run into that in at least their region yet.
Yeah.
So
yeah, I checked out your guys' LinkedIn. There's definitely a lot of activity there with the trade shows and stuff. So that's been working out well for you guys, because your plan right now is to go through installers primarily, right? And then maybe eventually go direct to consumer.
Well, the thing with direct to consumer, it's just like larger electric installs in the house. So most people will not tackle this installation by themselves. Most people will hire this out to a solar installer. So at least the latest numbers we were looking at is about like 80 to like 95% of people for these larger solar systems, they would have an external installer put it in. So just because there is a lot of electrician knowledge you have to know just to get it done right and to cope.
Yeah. So how are you handling that aspect of it? Because, you have to convince the installers it's a good idea, but then someone has to tell the consumer why it's a good idea for them too. So is there an incentive for the installer to upsell your product, or are you kind of educating the consumer first and then having the installer just do the installation?
Yeah, we've actually been focusing on the installers. So there's been a handful of direct customers that are kind of the more techie folks from my last example that are contacting us and have interest. Now on the installers though, this is another another product offering that they can have. So one large advantage to our system, for instance, that the installers love, is that the system is rather small, and it will have a good impact on energy savings within the household. So with the smaller system, we've had actually a number of installers now. I think it's been at least 5 or 6 installers that have made very similar comments, saying this is kind of like a good intro to solar system. So you have a system completely installed. They were estimating with our inverter cost at about $850 out to the installers. With the current prices for panels, their installation time, they're estimating about like a $4,000 install. It'll of course vary across the country at labor rates, how many panels you need, stuff like that. But that is a fraction of the cost from most grid-tied systems, which you sometimes see some of those going for $10,000, $20,000, $30,000, of course, depending how big you want the system. So it's a nice kind of intro to solar. And the flip side as well, if you're on the opposite end of the spectrum, like let's say you have a boatload of solar installed, you just want to keep adding solar. So on that end, you can't inject any more to the grid because your interconnection permit is going to have a limit. So what you could do is energy storage by some means. So either you just start adding batteries and never push that energy back out to the grid to exceed your cap, or with our device, we are using the water tank as the battery, much cheaper battery as well. So interestingly, the 50-gallon to 64-gallon water tank, which is average across the U.S., that stores about the same energy as a Tesla Powerwall.
No way.
Yes.
That's crazy.
Very similar. So you're talking like 10-ish to 12-ish kilowatt hours.
Wow. Mitch, you should put that on your homepage. I feel like that blows my mind that it's so similar to that. And it gives people a good frame of reference. I just wanted to say, Mitch, we see each other probably every day since we share an office. But I feel like I learned more about you in this 30-minute call than I did the years of knowing you. So I'm glad we did this. I think the audience will be excited to hear this. And thanks for coming on. Good luck with GreenPWR. Where can people go to kind of follow along and see what GreenPWR does next?
Yep. So you can go to our website. So that's greenpwr.com, or you can also find us on LinkedIn. Just give a search, and we're posting up there pretty regularly with updates on the product.
Awesome. Well, thanks for joining, Mitch, and good luck.
Great. Thanks, Videsh.